Okay, my name is Cece. I'm a software engineer on the experimentation platform team. I've joined Airbnb for around 10 months now. So pretty exciting here to share with you about how we do experimentation at Airbnb. Okay, where is my slides? Okay, yeah, that's my, okay. In my section, we will be cover some basics on experiment, and we will dive into how we do the experimentation, usage, drive growth, and then how we conduct the mobile experimentation. In the end, I will be talking about several specific challenges we are facing at Airbnb. So before I start, can you please raise your hands? Have you ever heard experimentation or A/B testing? Okay, and keep it raising if you have ever run an experiment. Okay, have you ever run an experiment but never heard about it? Okay, that doesn't make sense, but let's get start. I'm going to show you two screens here. Airbnb recently launched experiments. Now you can book a trip on our app. Here is a surfing trip hosted by Garrett in LA. Now I want you to feel which screen, left or right, will make you feel like you want to take further action on. So left or right? Okay. So people seems confused. What's the difference between them? The content on the button is different. So that one could like potentially affect a little bit. I'm not sure people make the decision because they notice that. If you open the app and go to any trip of this page, this button could also it could be shown as a see date. So this one is our running experiment right now. Depends on which group you're gonna assign. You will see the different content for this button. Here is another example. It's also is a running experiment. This one is shows a lovely home in Lake Tahoe. Let's try it again. Left or right. What makes you want to click the book button? Because this time the button's same. Yeah. Okay. So if you notice here with a very small reminder, here it says, yeah. Okay, you won't be charged yet. So as you see, like you will be experiments even without noticing it, and some different UI even with very small change will affect user experiments and then impact our user conversion differently. So why do we need to experiment exactly? Here is a chart showing the impact of the new feature. The horizontal axis is the timeline, the vertical is the volume. And a new feature was introduced at November. And there we will see a very nice uplift following that. Can we say, based on this chart, the new feature is actually attract more volume? Yeah, thank you. Probably not, because we do not know what would happen if we did not launch it. What if the organic growth was just like the green line, and the new feature is actually lower the volume? This is why we need experimentation. It helps us to access the impact of a new feature by only targeting a very small percentage of a user before you make it generally available. So an experiment essentially is just you have a hypothesis you want to verify. So this is a typical formula of it. It's like I believe who or what or which metrics you believe it will behave like this in what kind of a measurable way in a certain time period. So by answering all this, you'll be able to design an experiment. Next, I want to share with you a quote. I personally liked it a lot. It says, controlled experiments are the fundamental building block of decision-making at Airbnb. So this one is a demonstrates how important experimentation is for Airbnb. So who said that? It comes from a software engineer here, Jason. So not long after Jason has this epiphany, now he is our director of guest growth. So yeah, free tips for your career development. So I believe everyone now in this room is believing we should do it, and so about how. To enable experimentation, our team has built out an in-house platform. This platform is accessible for everyone in this company and help them to detect bugs and make the informed decision. I'd like to share with you some numbers about this tool. So if anyone can quickly tell me how many windows in this picture? Thank you for trying, I'm joking. Here is the real numbers I want to share. At Airbnb, we launched over like 100 experiments, well-designed experiments per week. We tracked more than 2,000 metrics, different metrics, and including some very important ones like user creation, the rate of the contact host, and also we have 60% of the engineers, the PMs, data scientists using our platform each week. And what the rest, 40% of them doing, they're doing the infrastructure and the security, just for the record. They only allow two, yeah. More numbers here, our platform supporting 10 different programming language. Basically, if you want to run experiment in any component in our system, you are allowed to do that. And our server is taking 20,000 requests per second, asking for allocation service. 70% of our compute in our entire data warehousing is just to supporting this experimentation purpose. This is the team behind this powerful platform. We have 1 PM for software engineer, 2 data engineers, and 1 data scientist. And the only point of my talk today, we are hiring. Okay. Thank you for staying here. And I'm going to walk you through another very detailed example we designed to have here for the experiment. So an important concept in experimentation is customer funnel. Sorry. Every business has their own customer funnel, which is a process to convert a first-time visitor user to end customer. At Airbnb, we have a lot of first-time visitors coming to our website, our mobile app, and they're at the top of this funnel. And some of them will just looking around, browsing, searching for their homes and trips. Some of them will create account and then contact the host. Then even less of them will actually call to make a booking. So driver growth, our goal is to make the conversion rate as high as we can. To decide that, we encourage our existing user to refer their friends. So they can send them to like a $25 coupon. The new user can enter a coupon code when they make a payment to redeem it. So, but the booking rate did not increase as high as we expected. So to drive the conversion, we designed the experiment. Basically, this experiment that keep reminding user of this $25 free money, and we show this small pop-ups basically everywhere, and then we also show and highlight the discount in the breakdown to just ask like, why would you not want to use it now? So when they see something they like, it's more likely for them to make a booking. This new experiment can increase this conversion rate significantly high. So this is a typical example of how we drive growth at Airbnb. This is just one of the thousands experiments we ran last year. So those experiments we designed covered a wide range of features, platforms, applications, from front end to back end, and from the web to the mobile. As the mobile devices are becoming more and more popular, we see very strong mobile growth at Airbnb. Nowadays, our growth in mobile has far outpaced our web user growth. Because of this exponential growth in mobile, Airbnb has put great effort last year in this area. And our team has also put a lot of resources to developing and improving the mobile experimentation. So during this process, of course, we encountered a lot of mobile-specific challenges. I'd like to share one of them with you today. This issue we call the time skew. Before we dive into what exactly time skew issue means, I'd like to walk you everyone through about how the data on the mobile got uploaded to server. So these two lines is the timeline, one's client time, one server time. And this is the dots, it means during the time that event's happening. And they want to log all of them, they could present like one user click a certain button, when the user jump to another page. All these events is the source for you to do the data analysis. Let's say for each minute, you want to package them and upload it to the server. It's a network call, so it takes a little bit time for server to receive them. The difference between the upload file and receive the time, it could cause delay by a network delay, the package loss, even worse, the app will crash before the upload happen. So for that case, you have to wait next time user bring the app back, then they have to try it again. So based on this diagram, and we will know the receive time on the server side and not be useful for us because it's too late. So the only time we can use it is on the client side. But what if this time cannot be trusted? This is the only time resource we having for do the experimentation for mobile devices. So yeah, how could it not be trusted? Is anyone familiar with this screen? No? Yeah, this is a mobile game called Two Dots. It's my favorite game. And how about this one? That is Candy Crush. So both of them are complaining you're out of a life, and you have to wait another 20 or 30 minutes to a next life generated. But I don't want to wait, right? I have a lot of friends wait there for me to beat. So Google gives me the solution. Basically, you just need to go to the channel and the setting, turn off the automatically daytime updates, and you set your system time to future. So you just have set the time to 3 hours later, you have a full life. And you can keep doing this, and you have unlimited life. Yeah, that's the benefit I'm cheating on this game. See how far away is the second place behind me, the Joey here. Yeah, don't tell him. Okay, so cheating on the mobile game is one of the reasons causing time skew. And also, it's people travel across time zones for some reason still want to use the app, which is happened a lot for Airbnb app. So all the events is happened and got logged with a wrong time. And they will upload when they get the connection, but the timestamp is actually wrong. And for many other reasons, people want to set the daytime manually. And if you are a mobile engineer, you will know the iOS or Android, they provide the APIs to give you the current timestamp is actually just the system war time. So based on our data, there is around 5% iOS, 10% Android. Their device time skew is big enough to affect our experimentation metrics results. The solution is we're using the NTP. It's a network time protocol. This is an internet protocol used to synchronize the clocks for the computers with the same time reference. And make this simpler. Whenever a user opens the app, you send out the NTP request. And depends on what kind of a time server you are calling. And you could call in giving back a timestamp of network time or the offset between network time and the system time. And when you got it, you save it in a cache. Whenever the event happens, you associate with this time instead of the system time. The tricky part here is the server could not return to you. And also it takes time because it's a network call. And before you use it, make sure you have the mechanism to verify this time set is still valid. As we discussed earlier, so one of the key components of experiment hypothesis is quantifiable metrics. I'm pretty sure like everyone will know about the business metrics here, but I'm not sure is everyone familiar with operational metrics. Operational metrics are used to measure the performance of a system and apps. So I'm going to show you some example for both of them. This one is a metrics for the business purpose. So not only us cares about it, of course. So basically, for the different business, we'll have from some metrics here you care about a lot. So the purpose is running the experiment. We're trying to have effects to this business metrics, but not all the experiments is getting a very good result for the new feature. So that's the whole point of we do experimenting. But we definitely don't want to hurt them because the code bugs. Operational metrics are here to help. After deploying a new feature, usually developers will go to the dashboards to check the performance and error rate. There is tons of tools there, the Neuralink, Bugsnag, Hockey App. I'm sure you heard some of them. But for those features, usually they launched behind an experiment. So at the beginning of the experiment, you start a very small percentage of the user. The change may not affect enough user to give developers a proper signal of the increase of the error rate or performance hits. So that creates a very big lag time between the deployment and the discovering the adverse effects. So especially for the mobile device, to release a bug fix as an app, it takes weeks. Here is an example of original metrics. We measure mobile app screens, TTI. TTI stands for time to interact. It means how long a user needs to wait before they can actually do anything with the screen. So this chart tells you for a given experiment, user gonna split it to two groups, one control, one treatment. And for each of the group, we are measuring the TTIs for different pages. In this example, they have a home page, a listing, rooms, inbox page. So what we can tell from this chart. Yeah, this is a terrible way to visualize the data. Let's try again from another dimension. Let's put the screen comparison together. Now it's very obvious something is wrong with the listing page. The TTI got increased more than 40% in this treatment group. Although it's still faster than the inbox or room page, but we can confidently say its performance was hit due to this new feature. So if you're user owner, you probably want to go and fix it right now. So operational metrics aim to help developers find out the problems at the early state. Because of that, the only real-time operational metrics is helpful. In this slides, I'm going to show you the diagram of how to make these metrics real-time. In our system, we have a lot of components we can run experiments. So Monorail is our main app, and also we have a lot of Java microservice. The JavaScript maintains some page load time and also of course mobile. So they send out this data to Kafka. So the arrows here is the main data flow. What kind of a data is this one? It means they are representing the experiment segments data, which means it's like for this data we are telling how we have an ID to who, whatever ID it is, could be listing, user, or visitor. Then this user got to be delivered an experiment. So there was a Spark job picking that data up and saves them to HBase, creating a mapping table real time. So this mapping table maintains a relationship between the IDs and the experiment's information. There is another set of data keep sending from the components. So the green lines means all the operational data. Means when the user got an error and got an exception happened, the app crashed, load time, all of this with ID and send out to Kafka 2. Another job will pick that up and trying to look up from the looking table and save the aggregates into Druid database. Druid database provides very low latency queries for massive data. You guys will learn more in the next talk. And above that, we save some summary data into MySQL, like hourly, daily, weekly for the future reference. Above this, all the data resource, we can create a alerting system and then, of course, data visualization. So yeah. Okay, don't take a picture. Cool. Finally, we can talk about some specific challenges we are facing here at Airbnb. We have a lot, of course, but I will just cover several of them. So as you know, Airbnb serves both guests and hosts. So the behavior of these two groups are completely different. So which means we have to track different metrics for different groups and also design the experiments differently. The challenge is how can we avoid gross cannibalization, meaning we need to make an experiment designed to accelerate user growth, but at the same time, please don't hurt host growth. So that one is our main challenging. And another one is how can we reduce the experiment runtime? As we talked about earlier about the customer funnel, usually this funnel is from the top to the bottom. It takes 2 weeks on average. So this is a very long process as I compare. You will hit the like or share button on Facebook, pretty much seconds. And then the same probably go to with Pinterest. You will pin something immediately. So that's the entire funnel for them. And for us, when you want to go to a trip, you probably need to discuss a lot with your travel partners and showing them around what kind of a film you find and discuss with your parents, your grandma, everyone on the trip, and compare with the neighborhoods of your destination. All of this takes up to 2 or 3 weeks. Some will take months, of course. So how to speed up the runtime of the experiments is like the key to help Airbnb move faster. The last but not least, going to the trip is a kind of a big deal. So each trip should be a unique experience and all should be memorable, especially when users don't necessarily travel that often. Because of that, the frequency of people using our products is relatively low. That makes our sample size smaller. So how to obtain power in experiments is another big challenge we have in here. So thank you for thank you for staying with me. If you have any suggestions or ideas, you're more than welcome to talk to us. And I forgot to actually introduce our team, by the way. Can my team raise your hands, like so people can find you later? Okay, so Nikki and Gabe is the end, our PM and my manager there. Okay, yeah, and great, our recruiters there. So you know where to find them. To recap what I covered today. So in the past 20 minutes, or how long I actually don't know, sorry. Probably late. So we started by explaining how importance of the experimentation, and then we shared how we drive growth, use the experiments, and work through one specific mobile challenging. Also, we wrap up some unique challenges we're facing at Airbnb because of our business model. So I hope you will find our work interesting, and even better, you can have any takeaways. So, okay, thank you again for being here. So. Do I have time to take questions? Yeah, okay. Okay. Anyone can catch that, you can ask question.
Is this a microphone? Oh, hi.
Yeah, it's a microphone. Hi.
So I run the data science team at change.org.
Okay, come close. I can't hear you.
Up here?
Yeah.
So we're also really big into experimentation. It's kind of everything we roll out. We want to do lots of experiments. An issue that we run into is getting the web engineers to clean up after themselves. So rather than using HBase and Druid, we're using Cassandra and Redshift to store very similar types of data. And over time, the experiments add up, they bog down the code base, they lower velocity for the web devs, they increase the amount of storage we need in Cassandra. How do you force your web teams to clean up after themselves?
Okay, so thank you so much. That's a really great question. And I didn't cover a lot about the specifically for our tool today. We definitely have the same problem. And for us, one experiment running is very expensive. As you know, our funnels, we want to cover everyone. our, is that thing can share? So our pipeline running every midnight is not running incrementally. So it's a look back as the first day you launch this experiment. So which means it makes it running is more and more expensive by the timing. So what we do is like, this is still in process work. We haven't do that yet. So we have the data engineer and data infra team help us like break down how the computers we're using and data warehousing. And of course, we have the view from AWS. So we're gonna send this to the team and then remind them like how much you are costing to of this experiment we are running. So if you feel shame about the bill numbers, you probably want to take a look at it more often and make decisions. But we are not pushing them to make decisions soon because we have another system calling them to give a suggestion, like what's the next step. You should even wait or you should like discard this feature. So yeah. That's what we do. Hope that's answered your question.
Hi, thanks for your talk. 2 questions. The first question is just specifically, how do you evaluate your A/B experiments? Do you use a traditional chi-square distribution or do you do something Bayesian? And secondly, given the number of experiments you run, how do you deal with the fact that probabilistically you will get a lot of false positives and false negatives?
Oh yeah, so we do that like pretty typical. For the first question, we actually, so we run, like we compare the p-values and other power things, and we provide the confidence intervals for them. And we have like repeat a lot of different signals on our page to show them like how this tool confidence about this result. And we have like different confidence levels to show them when we describe the entire very complicated matrix table for them. And also as we said, we are developing a tool called Make the Outcome Decision Guidance. So we can detect some metrics is obviously lower than they expect. We will warning them to say, if you want to launch this, it's probably not good. But that is what we do. And also, basically, our key, to answer the question is like we will repeat the signals with the different, like the border numbers and also the tracks, the stars everywhere to show them is like to describe how confident we are about it. Yeah.
We have time for 2 more questions.
Hi. Okay, it's broken. All right.
Does it work? Oh, it's working? Cool.
Yeah, I just hit it, yeah.
So thanks for presentation, a very vivid demo on some features. I just have a quick question on, does your tool support multivariate testing as well? And can you, if so, can you please share your general experience doing such kind of testing?
Okay. Multivariable testing.
Do you want to repeat the question?
Oh yeah. So the question is like asking about our tool supporting the multivariate testing. So to those not familiar with that, is basically you want to run the different features test within one experiment. Let's say there is a one page, you both change the numbers or the colors of the button or the shapes of the button, and you run them in the same experiment. So as a platform, we're not limited how people want to use this tool, but we on the back end, we generally not suggest people do that. It definitely will save a lot of time if you have like the package or the experiment you want to test it. But as we mentioned, the challenging, the third one, our sample size is fairly low. So when you want to do the multivariate testing, you probably need to split the traffic into smaller. So now we do is we split 50 and 50. And if you want to do multivariate, you probably need to split 2 quarters, 6 8. So we not support that because our challenges here. Thank you.
Hey, Cece. real quick. Hi, guys. I'm Dan. I'm on the data science team. Jump in on that one real quick. Yeah, our main experimental flow is just different treatments. So we're not supporting multivariate testing right now. But what we do is expose the data from our experimental pipeline to the teams using it. So if they do want to do additional analysis like that, they can kind of jump in and do any other analysis they want.
Thank you, Dan. Yeah, he's an expert.
Hey,
Hi.
thank you for the presentation. My question is, given the volume of tests that you're running concurrently, how do you account for the possibility that an experiment that really went awry or did incredibly well is affecting other experiments that might just be middle of the run or no signal otherwise?
Do you want to answer that, data scientist?
So I think the question was, how do we account for one experiment interfering with another experiment? Is that about right? Yeah. So we don't have an automated way to catch that. We do expose a sort of slice and dice tool that allows you to have one experiment be a dimension for another one. And so this is solved primarily through analysts being aware of other experiments on similar touch points and then doing that cut and seeing if there is a big change when you're in both experiments. But yeah, right now we don't have an automated solution.
One last question.
Hi.
Does this work? Yeah. Does your offline platforms like emails and app notifications and those things also go via the experimentation platform, or is it just on the site?
You mean what different types of experiments we're supporting?
Yeah. Like, for example, if you're doing subject line testing on emails or creative testing on emails, or
if you remember the dialogue I showed earlier for the IDs, we are not specific just for the users who visiting us, and also the ID could be device. It's also ID could be a listing. So for the different listing, we can also bucketing them to different experiments. We also support the email list. And for the different email, we have a different design standout. And recently, we're supporting the WeChat ID as well. As I can remember, we're also supporting some third-party experiment can running. Let's say we use the Apple Boy to supporting us to do the notification. So they will actually help us do the bucketing, and we will just take the data analytics. Yeah, hope that answered. Thank you.
Awesome.
Okay.
Give a round of applause to Cece.
Thank you so much.
All right, awesome talk. All right, we're in for a treat for this next one. So our next speaker, Gian, he's actually one of the co-founders of MetaMarkets, as well as this company called Imply, which does data visualization on top of Druid. Druid is absolutely one of my favorite technologies because it's one of the only technologies that can really do like multi-billion record slicing and dicing. So really excited to have Gian. Can everyone give him a big round of applause?
Hey everybody. Also, sorry to disappoint you. I didn't actually found MetaMarkets. I just worked there. I did found Imply, though. Anyway, I really want to thank Airbnb for inviting me to speak here. It's really an honor. As you've heard before, they use Druid, and they actually did a lot of really cool stuff with Druid that I'll be touching on a little bit in this talk. So I'm here to talk about Druid, which is a high-performance, column-oriented distributed data store that I've been working on for the past 3 years and has existed for, I think, the past four and a half years at this point. It was started at the company I used to work at, MetaMarkets, and the company I work at now, Imply, is a company that's really just devoted to Druid. Actually, before we get started, how many people have heard of Druid or used Druid? Wow, that's a lot. We're doing a good job. How many people are into databases in general? Okay, well, everyone who didn't raise your hands, I hope you're not too bored in the next 15 minutes. So first, let's peel apart the tagline. So there's 4 parts to the tagline. They're all there for a reason. The first part, high performance, what that's about is that we target sub-second queries. And that's because we're really trying to power interactive experiences. The column-oriented thing, we're buzzword compliant. Column-oriented is really cool now, and we're that too. We're distributed, so we scale out on commodity hardware. Big data is no problem. And we're a data store, so we're not querying your data that lives somewhere else. A copy of your data will live in Druid. So why are we here? This is a tweet I love from an account that sadly has stopped tweeting a couple of years ago. It's really a loss in the Twitter sphere, but this one is true. Problems are important. Solutions are a little bit less important without problems. So the problem that we're trying to solve with Druid is powering interactive exploration of data, these interactive data experiences. In particular, we're trying to help people look under the hood of reports and dashboards. So instead of just generating reports, instead of having dashboards that are lightly interactive, maybe a slider, we want everything to be fully interactive. And we want the data fresh too, so we're reflecting things that are happening right now. Hopefully this slide animates. Yeah, there we go. So the top right and bottom left pictures are a UI called Superset that's actually made here at Airbnb. I don't know if the team that works on that is here. If you could raise your hands. There we go. Yeah, it's a really awesome tool. It's an open source UI that's not just for Druid, but I think Druid's the best thing to put it in front of. And the top left and bottom right are the Imply product that we build at Imply, that the guy that's in charge of that team is over there. And both of these UIs are really good examples of the kinds of UIs that Druid is meant to power, these really interactive UIs. So it's no coincidence that both projects decided to put animated GIFs on their home pages. The sort of interactive, visual, exploratory nature is really the kind of thing we're trying to make happen. So what are the challenges to making this sort of thing happen? Well, the first challenge is high dimensionality. A lot of data sets these days have tens or hundreds of dimensions. But dimensions, I mean things like keywords or what kind of device someone is on or geolocation, that kind of stuff. So there's a lot of dimensionality. And that dimensionality means there's too much fine grain to pre-compute anything. So you see a lot of people saying, well, pre-computation is dead. We have to do full scans. They're largely right. Druid also does indexes, but the full scan being fast is something that is important. Multi-tenancy is also a thing. We want to have a lot of concurrent users be able to use these interactive dashboards at the same time. Freshness is a challenge. We want to load from streams, not just from batch files, because we want to reflect data that is recent. And scale is important too. We want to be able to scale out cheaply, because for a lot of the streams that we deal with in Druid, individual events may be pretty low value. It seems like at Airbnb that's not necessarily the case, because the individual events are leading towards pretty big purchases, but a lot of people using Druid are using it for pretty low value events, like actions being taken in mobile games and stuff like that. So the motivation for all this is that if we can build a data store that does sub-second responses on large amounts of data, then that allows you to have a dialogue with your data. This rapid iteration on questions will remove barriers to understanding. The idea is that when you're using a tool like Superset or like Imply or like one of the other many tools built on Druid, you're doing an iterative process where you're asking a question, getting an answer, then the answer just spurs more questions. You ask more questions, get more answers, and it's very important this process be fast and iterative. If at any point the system is so slow that you get up and get a coffee, we've kind of lost. So back to Druid. Druid is something I didn't mention before, open source, column-oriented data store. We support low latency ingestion from Kafka and from other streams. So the Cece, who just talked, showed a diagram that she had a lot better graphics than I do, but she showed a diagram of their web servers feeding into Kafka, feeding into Druid, which is a very typical setup for Druid. Druid's designed to support ad hoc queries so that we don't pre-compute things. The data is all being queried on the fly. We do both exact and approximate algorithms. So the idea is that the approximate algorithms can give you answers a lot faster with bounded error. And if you really need to firm up an answer, you can. But for a lot of these exploratory interactive use cases, approximate answers tend to actually work out pretty well. We can keep a lot of history. Years are OK. And that's what's pretty typical is months to years of history. And it is a growing open source community. So the project's been open source for, I think at this point, a little over 4 years. And there's over 150 contributors since then. And again, Druid is focused on making interactive data exploration fast and flexible. So let's talk about some common uses of Druid. One really common one is user activity or entity activity in general. So if you have fast ad hoc queries of a high dimensional activity data set, that can power a lot of cool stuff. So one thing that Druid can do is you can do a top-end query, which gives you the heavy hitters by some metric. So you can use that to find interesting user segments. You can find top countries, top cities, top regions, top devices by something. And often just looking at a variety of top ends over various dimensions will lead you to something interesting. And the fact that Druid can generate these very rapidly allows you to sort of explore through your data and find interesting things. You can use hyperloglog, another approximate algorithm, to count users. You can use theta sketches, another approximate algorithm that we have, to count users that did two things, or did A and B, so bought product A and bought product B, or did A and not B, maybe bought product A and did not buy product B. And these, again, are also approximate answers that you're going to get. And you can also define arbitrary user segments and see how they behave interactively. So I'm not sure if this is what Airbnb is doing with the Druid diagram that was up earlier, but you could define a user segment that matches the people in an experiment and see various metrics for people in that segment. And because you can define these ad hoc, there's no need to pre-compute anything. And if you start a new experiment, then you can define a new segment immediately and have an answer within a second. Another thing Druid's commonly used for is marketplaces. Some stuff you can do with Druid and marketplaces, you can track market activity in real time. You can identify anomalously high or anomalously low activity in any market slice you can think of. You can try to understand behaviors of groups of participants, again with ad hoc groupings. And one really common use for Druid in marketplaces in particular is to promote visibility. So there's a lot of companies out there that run marketplaces and use Druid to power a web app that their marketplace members can log into and see what's happening in the marketplace for their slice of transactions they're involved in. A lot of people that deploy Druid in that way find that the visibility for marketplace participants really helps them stay involved. Another big one is DevOps. So you can track millions of time series. Each time series in Druid we modeled as a set of events over time with the same dimensions. And Druid can aggregate these time series on the fly. And we can also use our approximate algorithms. So we have an approximate quantile aggregator that we can use to compute approximate median, approximate 90th percentile, and so on over any group of events. So one typical way of handling this is on the machine, you can compute a 90th percentile and send it out. The problem with that is that only gives you 90th percentile for that machine. The best you can do then is average them. Really, averaging a bunch of 90th percentiles for a bunch of machines doesn't give you the actual 90th percentile for the whole set of machines. That's not really how percentiles work. So in Druid, we actually aggregate them properly, and you get much more, even though they're approximate, you get much more accurate percentiles over groups of things. So I'll talk a bit now about the tech side of Druid and how it does what it does and how it's organized. So Druid by the numbers. The largest cluster that I'm aware of is generating about 500,000 events per second ingested, so a little over 40 billion events per day, and on average, and at peak, 2 million events per second. So that's doing about 10 to 100,000 events per second per CPU. The reason for that range is you get 100,000 in the benchmarks that we publish, and you get 10,000 in real life. We have a Druid white paper that is a little bit out of date in terms of the numbers, but this is from the original cluster that we were operating back when Druid was created. So that cluster had 10 terabytes of data, 50 billion rows. The mean query time over those 50 billion rows was half a second. The 90th percentile was less than a second, 95th percentile less than 5 seconds, and the vast majority, 99%, were less than 10 seconds. So by and large, on that 10 terabyte data set, we were achieving sub-second response time for at least 90% of the queries, and the remaining 10% weren't that bad. Druid's pretty easy to query, so there's visual tools, which for new users, the easiest way, and even for power users, I prefer them because they're visual and everyone likes visual things. So superset and imply are the two I showed earlier. I think they're probably the two best ones. PyDruid is a library we have for Python. We have RDruid for R, and we have Plywood for its native TypeScript library. It'll also work in JavaScript. There is a SQL interface. There's actually 2 SQL interfaces. And Druid's native language is JSON over HTTP. A little bit more about the approximate algorithms. So like I said earlier, we have both approximate and exact algorithms for a lot of questions. The first one, hyperloglog for distinct count. This, at the time we introduced it, it was pretty unique. It's not unique anymore. Everyone has it these days. It's super popular. The other 3 are still fairly unique. So top ends, we have approximate rankings by a chosen metric. So this is essentially a group by something, order by something else, limit something. And doing this approximately will be a lot faster than doing it exactly. We have approximate histograms, and that same basic technology can be used to do both histograms and quantiles. And we have theta sketches, which were contributed by Yahoo. They use them there for behavioral analysis, and that's their big use. So they're like hyperloglogs, and they do approximate distinct counts. But the difference is that hyperloglogs can only handle unions. Theta sketches can also handle set intersections and set differences. So they can find people that did both A and B or A and not B and stuff like that. So they're a bit more flexible than hyperloglogs. Another cool Druid feature is rollup. So we can do partial aggregation at ingestion time by combining similar events into one Druid row. And by similar events, I just mean 2 events that have the same set of dimensions. So if you have 2 users that are on the same device from the same country, same region, same dimensions, and whatever you care about, they'll end up in the same row in Druid. And so this is a form of compression. It can be useless. So if you have a column that's unique, like if you have a UUID column or a primary key column, this doesn't do anything. But on a lot of real-world data sets, especially entity activity data sets like user activity, the compression is pretty good. So 10 to 1, 30 to 1, 100 to 1 are pretty common things to see. And this is similar to what a lot of people do with partial aggregation as an ETL job, but the difference with Druid is we do it natively inside the database. The Druid physical storage and query system is pretty simple, and its simplicity is actually the key to its speed. So it's all based on the concept of time-partitioned immutable shards. So a Druid cluster is composed of hundreds or thousands or even millions of shards that are each about 1 gigabyte in size. And those shards are partitioned by time. There's a global index of time interval to shard. And what that allows is it takes advantage of the fact that most queries are going to have some kind of time filter. Usually you're interested in past day, past week, past month, something like that. And so we can really quickly dial down to the shards for your time range. Once we're there, every shard is column-oriented and compressed, and every shard also contains indexes for fast filtering. So we're not we're not afraid to do full scans with Druid. Full scans are fast, but we won't do full scans if we don't have to, because we do have indexes. And Druid's all based on computing partial results locally and then merging hierarchically. So you're never going to have all of your Druid data nodes sending all of their data to some query node. It'll do as much aggregation as it can locally and then forward on a little bit to the query node for merging. So like I said, Druid's open source. You can try this at home. So you can get Druid from the official website, druid.io, or you can get our distribution from our website and imply.io. They're largely similar. The difference is that the imply one just has a few more goodies in it. You can connect Druid to things. Like I said earlier, Druid has a copy of your data, so it loads data from a variety of places. So the most popular ones are Kafka, Hadoop, S3, and a variety of stream processors that we support loading from. You can also contribute, because it's open source. It's Apache licensed, and we're on GitHub at that link over there. And we have a community page at druid.io/community that describes how to contribute, how to get started with pull requests and issues and all that kind of good stuff. And thank you, Airbnb.
We have time for just several questions. And then maybe after each question, just repeat after the person who asked it.
Hello.
Hey.
So you mentioned the approximate algorithms. Are they deterministic?
The question is, are the approximate algorithms deterministic? They are largely sensitive to the order things are merged in, so largely no. The hyperlog one is pretty stable. The theta sketch one is also relatively stable. The approximate histograms is relatively unstable. So you're likely to get a different answer every time you run it. They're not going to be that different. So they all have bounded error, and I guess I wouldn't be too scared of getting a different answer every time you run it, because they'll all be within whatever percent. So for hyperlog it's 3%. For the others, it varies of the true answer.
Thank you for the talk. I'll ask you to be as honest as you can, but I know you have a little bit of bias. But what are the pros and cons of using Druid to some of the other tools out there?
So the question is, what are the pros and cons of Druid versus other stuff? Do you have anything else particular in mind? I can be super honest.
I'll give you an easy one. What about like Vertica, for example?
Okay, so Druid versus Vertica. I would say that Vertica is a very mature data warehousey SQL database. It supports a lot of features that Druid doesn't have. So Druid doesn't have joins is one really big thing. Druid also doesn't support SQL window functions is something that matters to some people. So there's a lot of features that Vertica supports that we don't. We are open source. That's cool. They're not. Our real-time stream loading is a lot higher performance than theirs. So in Vertica, you do a trickle load. There's limits to how much you can ingest. It doesn't scale very well. The real-time loading in Druid scales horizontally pretty much because the locking is very hands-off. So I would say our strengths are in the area of streaming, being open source. We have a couple more approximate algorithms they don't have. They have hyperlog, but they don't have anything like the approximate top-end stuff that we do or theta sketches. And their strengths are in sort of just to support a lot more SQL features than we do.
We'll take one more question. Good. Okay, cool. Well, thank you so much, Gian. And please give him a round of applause.
Thanks, guys.
All right, one thing I wanted to mention about tonight is that all the proceeds from tonight's talk are actually going to Women Who Code. So thank you so much for attending and participating and for helping this great cause. So this next talk is something I'm personally, very excited about. It came out of a brainstorm idea we had about 7 or 8 months ago about how can we possibly democratize data across all of Airbnb and make data more searchable, more discoverable, and more consumable. So I'd love to welcome Chris as well as John. Actually, John first to the stage. to talk about the Dataportal.
Hi, I'm John, a software engineer here at Airbnb. Tonight, Chris and I are going to talk about the Dataportal. It's an internal tool we're developing to aid with the data discovery and decision making. So firstly, the problem we're going to try to describe tonight and what the Dataportal project really attempts to address is the proliferation of tribal knowledge. As Airbnb grows, so do the challenges around the volume, the complexity and obscurity of data. And tribal knowledge really only reaches so far. In a large, sort of complex organization with a sea of data, users often struggle to find the right data. Data is often siloed or lacks context. So that could be a table without a description, or it could be an isolated data resource. And often sort of data without context is meaningless. So I am a recovering data scientist who wants to sort of democratize data, to automate common workflows, to surface relevant information, and to provide context. So at Airbnb, we have over 100,000 tables in our Hive data warehouse. And when I joined last year, it wasn't evident, actually, how one can actually find the right table. So we built a prototype, leveraging previous insights, giving users the ability to search the table metadata. We actually quickly realized that we were kind of myopic in our thinking, and we should really expand this beyond just data tables. So at Airbnb, we have a number of different data resources. We have over 6,000 superset charts and dashboards. We have over 5,000 experiments and metrics. There are over 4,000 Tableau dashboards and workbooks, and 1,000 knowledge posts, as well as like a litany of other data types. But most importantly, we have over 3,000 employees here. And I really can't stress enough like how valuable people are as a data resource. Surfacing who may be the point of contact for a resource is so pertinent for efficient knowledge sharing. To further complicate matters, we are dispersed geographically. We have over 20 offices around the world. So what's the mandate here? Simply put, we want to democratize data and empower Airbnb employees to be data informed by aiding in the exploration, discovery, and trust. And hopefully, together, we will make data great again. So what's the concept? So at a very high level, our desire is to really just search for something. The question then is, like, how do we frame our data in a way that is meaningful for searching? So it should be fairly evident, like, what we're going to feed into our search index. It's all these data resources and their associated metadata. The real question is, are we missing something here? And we think yes, like, quite clearly, our ecosystem is a graph. All these data resources are nodes, and the connections are just relationships or edges in that graph. And we want to leverage that. So relationships are extremely pertinent here. So nodes and relationships have equal standing. So just knowing who created a resource or consumed a resource is just as important as the resource itself. So we actually gather data from a lot of disjoint tools, and it'd be great if we could sort of provide additional context around this. So let's walk through a hypothetical example here. So a user consumes a Tableau chart which lacks some type of context. We know that piecing things together, this is actually from a Tableau workbook that another user created at some stage. So now we have this lovely indirect relationship between these people. The creator can serve as a point of contact for the user to reach out to with questions. Digging a little further, we can actually discover that the workbook was derived from an aggregated Hive table, which exposes the user to that data. This is sort of non-trivial in Tableau at the moment, right? If we dig a little further, if we pass the Hive audit logs, we can actually determine what table that table was derived from. And that may be some additional data that we're providing. And finally, both these tables are associated with the same like Hive namespace or database. And there could be some additional metadata there as well. So that's sort of fundamentally what our graph looks like. So what about the construction of the graph? So we start off with about 5 different databases. We have 3 APIs, and we use these to create a graph of nodes and relationships. And we use an Airflow DAG, which is just an ETL system, to actually build this graph. This Airflow DAG runs every night, and we export the results to Hive. Additionally, we have over 10,000 thumbnails that we generate from various sources. So there's a Tableau API. Knowledge Repo has a database, and we actually go through and scrape all of our superset assets to create thumbnails. The idea here as well, we just want to bring up as much relevant information as possible to the user. So let's walk through a very simplified view of the data path, which in itself is a graph. So again, I mentioned earlier, given that relationships have parity with nodes, it's really pertinent that I ought to discuss the conduit that connects these systems. So firstly, as we said, so the data starts in Hive, as I mentioned before. We use Airflow to transfer the data to Python. And in that, we compute the page rank of the graph. And this significantly improves with the actual search ranking. So the data is then pushed into Neo4j, which is a graph database, using PyTornado, which is a Neo4j driver. And so, as I said, Neo4j is our graph database. It stores all the nodes and relationships. The nodes are then pushed via a GraphAware plugin to Elasticsearch. And this just serves as our search engine. And Elasticsearch is commonly used here at Airbnb. And finally, we use Flask, just as a lightweight Python web server. This is frequently used, actually, with a number of data tools. So Airflow, the Knowledge Repo, and Superset. So results from Elasticsearch are then fetched by the web server. And results from Neo4j queries, which contain all the connectivity information about the graph, are also fetched via that same PyTornado web driver. Driver. So why do we choose Neo4j? There are 4 main reasons. Firstly, given that our data is represented in a graph, it just makes logical sense that we use a graph database to store that data. Performance. Performance is key here. There are huge performance wins when using a graph database, especially for connected data. We don't have to deal with joins. Neo4j is the most popular graph database, and the community edition, which is what we use, is free, so that's a nice win. And it integrates really well. So it integrates well with Python, which is what we use, and Elasticsearch. So these are existing technologies here. There's a really beautiful sort of symbiotic relationship between Neo4j and Elasticsearch. And this is all courtesy of GraphAware, which is a third party. And they divide some plugins. So the first one lives in Neo4j, and it asynchronously syncs all the data from Neo4j to Elasticsearch. So that means we passively manage our Elasticsearch cluster. The second plugin actually lives in Elasticsearch, and it enables us to consult the Neo4j database during a search query, which enriches the search rankings by leveraging the graph technology. So here you could run a search, and you may want to filter on most consumed or recently created, and we can query out to the graph to get that information. So here's kind of an example. Neo4j will push to Elasticsearch via GraphAware. And similarly, GraphAware will pull from Neo4j again through the GraphAware plugin. And so finally, I want to discuss the schema. So here's an example of a relationship where the source node S created some target node T. And at this stage of my presentation, I was getting jaded with drawing graphs, so I'm going to switch to using Cypher. So Cypher is a declarative graph language which Neo4j uses, and it uses like ASCII art to represent patterns. So this relationship looks like this in Cypher. So here, entity represents a node label, which acts as a mechanism for grouping the nodes. Nodes can have an arbitrary number of these labels, and creator represents a relationship type. We define a node label hierarchy, and a subset of that is shown here. So for example, a user sort of belongs to an org, and entity is the sort of base kind of class we can think about it as a base entity. Our schema is created in such a way that nodes are globally unique if you combine the sets of labels and the ID property. So here in this example, a user is keyed by their LDAP name, so that guarantees uniqueness. A Hive table is keyed by the Hive table name if we include the database, so this is globally unique. And like a superset dashboard is just keyed by the DB ID that represents that dashboard. We know the stuff ahead of time, all the stuff lives inside of Hive. We want to be really efficient with how we do our graph queries. We want this thing to be super fast. And like most databases, Neo4j does have indices. The one sort of threat about this is it only works for a single label. And as I just showed you, we use multiple labels. Similarly, there are uniqueness constraints, which ensures that we don't duplicate data. However, these indices also only work for one label. So we need a resolution here, and bingo, it's GraphAware again. They have another plugin which gives you UUIDs. So what happens is it hooks into our data. Every time you write a transaction, it assigns a UUID property to that node. That property can never be deleted or changed. So this now enables us to define nodes like this. So we have an entity, global entity label. It has a UUID. It's globally unique. We can use an index on this. And thus we can have very, very efficient queries. So now I'm going to hand over to Chris, who's going to talk about the front end.
Test, cool. All right, thanks, John. Again, I'm Chris. I'm a data visualization engineer on the analytics and experimentation team here. And so now I'm going to, now that John has basically introduced this interesting and powerful graph of data resources that we have, I'm going to describe how we allow employees internally to harness its power through the web app. So John just spent like 10 minutes describing the complexity of the back end of this, and I think oftentimes with data tools, the back end is so complicated that the front end is often an afterthought. I think that this should never actually be the case, and in fact, the complexity and data density of these tools makes intentional design even more critical. Additionally, one of our project goals with this was to help build trust in data. And as users encounter painful or buggy interactions, these can chip away at trust and basically trust in your tool. On the other hand, a delightful data product can help build trust and confidence. Therefore, with the Dataportal, we wanted to embrace a product mindset from the start to ensure thoughtful UI and user experience. So to do this, we actually performed user interviews across the company to assess data needs, pain points around data resources, and tribal knowledge. So from these interviews, 3 user personas emerged that basically span a variety of data literacy levels. So we'll start with, first one I'm calling Daphne Data. So she's a technical data power user, the epitome of a tribal knowledge holder. She knows a lot about a lot, and she's frustrated by having to explain all the context to the data resources all the time. Next, we have Manager Mel. We'll say that she's a little bit less data literate, but she still needs to keep tabs on her team's resources, get context to what other teams are working on, etc. And finally, we have Nathan New. So he could be a new employee, or maybe he's just working with a team for the first time. In either case, he has no idea what's going on. He's completely lost and quickly needs to get ramped up on data resources. All right, so with these user personas in mind, we designed the app to facilitate data exploration, discovery, and trust through a variety of product features. I'll discuss in greater detail in the next few slides. So broadly, these include search, the ability to explore detailed information and metadata about these resources, and finally, user-centric, group or team-centric data and company-level data. So let's jump into these. So the data portal is primarily a data resource search engine, and so clearly it needs to have killer search functionality. So you can see from this screen capture that we tried to embrace a minimalistic design and also make the app feel pretty fast and snappy. As was true with Druid, slow interactions really disincentivize exploration. So now I'm going to call out some aspects of our search experience. At the top there, you can see some Google-inspired search filters. So rather than images, news items, videos, we have things like data sources, visualizations, users, teams, etc. Going on down in the search results, we have search cards that display a hierarchy of information. You can't see it too well there, but it includes things like the name, the type, highlighting search terms, the owner of the resource, number of viewers, so you can quickly gauge staleness, etc. Down at the bottom, we also try to show the top consumers of a given result set, basically to surface relationships and provide more context wherever possible. All right, so continuing this flow, from a search result, you typically will want the ability to explore a data resource in detail. So for that, we have content pages. This is an example of a Hive table content page. So at the top there, you have the description, you have a link to the external resource, as well as social features. So you can favorite something, you can also pin something to your group's page, which I'll discuss more in a second. Below that, we have metadata and information about consumption. So who created it, when it was updated, who has consumed it, etc. So often these data aren't available anywhere else. And that's what makes the data portal really cool. And as John said, it's the relationships between the nodes in our graph that really help provide context to gauge relevancy. Below there is another example. So another way to surface graph relationships is through related content. So, which in this case, we have a Hive table that powers several visualizations, and so we can surface the visualizations as links. The idea here is that we want to enable people to explore and pivot from node to node really easily. So who created this table? What else have they made? Are they flirting with me by favoriting my data resources? Things like that. Just kidding, we're not really Tinder. So going on from there, I want to just highlight some other Hive table features. So users can browse column details and value distributions on the fly. They can also view table lineage, so where is this table created from, what tables are created from it. And one thing we're really excited about is the ability to actually update and enrich the graph by modifying metadata on the fly. So you can update column comments and descriptions, and it's pushed directly to the Hive meta store. I just want to also point out that the content page for each of these data resources can be different. So this is just highlighting some like knowledge posts, dashboards, and visualizations. All right, so on to users. Users are the ultimate holders of tribal knowledge, so we created a dedicated page to reflect this. So on the left, you can get basic user details and metadata. On the right there, you can see that you can actually view the resources that the user frequently uses, things that they have created, favorited, and groups that they belong to. So to build trust, we wanted to be transparent about data. Users might be really interested in who is consuming their own data resources, or they might be interested in what their PM or their manager is actually looking at. Along the lines of data transparency, we also made a conscious choice to keep former employees in the graph. So if we take George here, the Studley intern that all the ladies talk about, he created things, he favorited things, and if I want to find that sweet dashboard he made that I forgot the name of, this can be really useful. So another source of tribal knowledge at Airbnb is teams. Teams have tables that they query, dashboards that they create and view regularly, their go-to metrics that they track, etc. In our interviews, we found that team members spend a lot of time telling people about these same resources, and they wanted the ability to link to these popular items. So on the left there, we have a generic group overview similar to the user page. But then to enable curating content, we decided to borrow some ideas from Pinterest. So group members can pin data resources to their page and organize them by sections. We leverage thumbnails of charts and dashboards, as John said, whenever possible to provide additional immediate context. One thing I also want to point out, so you can't quite see it there, it says curation and suggested content. So we have over 5,000 team pages in our graph. And the day that we rolled the Dataportal out, nobody would have pinned content, right? So we could either surface empty pages or we could try and generate some useful content automatically. So with our graph, we can actually do a pretty cool query where we take all of the members of this team, can look up what they consume on a regular basis, and then suggest that as content, basically to provide no context until the team has started doing the curation themselves. So I just wanted to show what these flows look like. On the left, you can pin things from a content page. On the right, you can kind of get a sense for the customizability of how you can change the layout and organize your resources on the fly. And lastly, we found in our user studies that employees are so engaged in their day-to-day jobs that sometimes they feel a little bit disconnected from the company level metrics. So we created a page that really just shows them up-to-date company level metrics that they can explore. And since this is a tech talk, I wanted to give a brief overview of the front-end tech stack that we're using here. Essentially, we have a single-page web app to help things feel fast. It talks to a Python Flask API, as John said. And then we're using ES6 and NPM for the application and dependencies. We use React for generating the DOM, Redux for the application state. We use a really cool library from Khan Academy called Aphrodite for styling. Because writing HTML and JavaScript is not enough, you can actually now write CSS in JavaScript, which is great. And then for testing, we use a pretty standard stack of ESLint, Mocha, Chai, Enzyme. So now I'm going to quickly highlight some of the challenges that we faced with the graph. So the first of these is complex dependencies. So as an umbrella data tool, the Dataportal is really vulnerable to changes in the upstream resource dependencies. So this can include things like schema changes on the back end, or it can include URL changes on the front end. Another challenge was data-dense design. So balancing functionality with minimalistic design is not that easy. So additionally, most internal design resources are not made for data-rich apps. So we had to do a lot of creation of these data-rich components ourselves. Another interesting challenge is graph merging. So if you imagine that we have the graph yesterday and compare it to today, nodes could have been added, they could have been deleted, we have new relationships, relationships go away. And so we have a non-trivial Git-like merging that has to happen. One specific example of this is graph flickering. So if you think about a relationship that is transient, so if I viewed a dashboard yesterday, but I didn't view it today, if you didn't correct for this temporal nature and make the graph robust to that, you would have this flickering effect where relationships would disappear and reappear the next day. All right, so I'll wrap up with some interesting future directions that we're either working on or scheming about. So the first of these, there are always new resource types to add to the graph. Each of these is interesting and will introduce more interesting relationships along with them. So these include things like A/B test, logging schemas, SQL queries, etc. Another cool idea that we're exploring is this idea of certified content. So if I'm trying to find a dashboard, I know the name of the dashboard, I search for it, and I get 5 results of the dashboard with the exact same name. How do I know which of those is relevant to me? So we're trying to use this idea of certification to build trust and enable users to filter through a sea of stale or irrelevant content. Another idea is moving away from this passive system of exploration to basically delivering relevant updates and content suggestions. So this could include things like your dashboard is broken, a group you're following just pinned new content, this table of yours hasn't been queried for 3 months and is costing us tens of thousands of dollars, things like this. And what feature set would be complete without gamification? So the major value add here would be potentially providing content producers with a sense of value. So you could do things like, you have created more content than any other user right now. Your dashboard is in the top 10 dashboards internally, etc. All right, so with that, I'll wrap up with shout outs to the team. So it's me and myself, John down there, Eli is an experienced designer. Michelle Thomas couldn't be here tonight, but she's a software engineer also on the team. And then, of course, Jeff, our product manager. So with that, thanks.
Awesome job. I think we have time for just several questions. And then if you have more questions after that, we'll be sticking around afterwards to take on other questions. So I see one question in the back.
Thanks, guys. This is really amazing. 2 questions, if I ask. So you mentioned Hive. So how do you track the usage of the assets? Do you parse every Hive query? Do you extract columns? And the second question is, are you planning to open source this amazing work, just as you did with like AirPal or Airflow? Thank you.
You should take the first question for sure.
So the DI team actually has done all of the work here, right? So we actually have audit logs. So every Hive query gets processed and we have a record in a table. That record contains actually all the inputs and the outputs of the query, as well as the query itself. So we're actually not doing any kind of query parsing on that. The one caveat is we're using AirPal queries, is not all Presto queries, and we have a lot of Presto queries, and we haven't got to the stage of actually running explain on hundreds of thousands of Presto queries. Is kind of just going to like double the number of Presto queries running a day. So we need to sort of move away and move towards like running like a parser on the SQL.
I could take the question about open sourcing it. Right now, that's not in our roadmap. I think the major issue is that the data resources are so specific to our internal data stack, and that probably is true at every single company around, that it would be hard to build like a generic tool for something like this. That actually makes it really nice internally to work on, though. So many of our projects are open source, and that's amazing. So knowledge repo, Superset, Airflow, things like that. But there are constraints that introduces as well. And so it's a balance, I would say.
You guys touched on this a little bit. You were talking about, how to clean up stale things. There's like 5 instances of something with the same name. I mean, I imagine with the volume that you guys are dealing with, that is like a pretty serious problem. I mean, I work at a much smaller company, and we already have all these things that are just complete resource hogs, and nobody's looking at them. So, like, how do you guys handle that stuff?
I can give some thoughts on this. I don't know, it's a pretty crazy problem. I think like some of the things that we already surface make it easy to navigate this a little bit. So things like, for the consumed edge in our graph, we basically that data is relevant for the last 30 days. So if you see numbers that like 20 people have consumed something, that's relevant to the last month. We didn't think it would be useful to surface that type of thing for like 4 years ago when somebody was looking at that. So the numbers that you see for consumption are relevant, and that helps to some extent. Like the favoriting, the pinning helps a little bit. But really, I think to address this correctly, you probably need like data stewards or people that own a particular data resource. And so that's why we're trying to explore this idea of certification, where you have like a certificate where somebody owns it and is responsible for updating it.
I'll just add one thing to that as well. So like I think ID user is a common column we have here, and there's like 16,000 tables with this column in it, right? So you only search for ID user, what do you show up? And PageRank really helps here as well. So when we build the graph, we get relevant tables coming out of that as well. So again, kind of addressing what Chris said as well, if lots of people are using that, that's going to boost the PageRank of that node. So that'll help when sort of Elasticsearch, the actual string query filter, won't give you any sort of additional sort of splitting or like differentiation between the nodes, but PageRank will. So it's kind of a trade-off between sort of the sort of passive sort of idea that the graph knows best versus what Chris is as well. Like sometimes you do need to really like put a firm stamp on things as well. We haven't done things like working out actually this table hasn't actually. It was temporal. There were date stamps, but it hasn't been run for the last sort of 6 months. We haven't really addressed those types of issues yet.
Well, that's a pretty cool direction to go in, I think.
So really awesome tool. But one of the issues with analyzing data, and I feel like, well, in life in general, is that you can get results when you know what kind of questions specifically to ask. But you know, a lot of times, so things with data is you don't know exactly what is it that you're looking for. Like, you know, I have a generic question, but exactly what tables will give me those combination of and give me a definitive answer. So how do you guys mitigate that?
So that's a good question. I think that basically that's a hard problem. And apart from doing something like natural language processing or like intercepting somebody's query and modifying it in certain ways for key search terms or something like that. That's the idea with having basically pivots or links to other things all over the place. So maybe I don't know exactly what I want, but I can find this page and I can see that somebody else has worked on that. I can go to their page and see what else they've viewed or created. I can go to team pages to get a rough idea of curated content as well as other content that they produce. So that's one approach.
Cool. Yeah, I think, just to add to that too as well, I think the more metadata we surface, the more relevant and topical things can be. So for example, you can actually stay at a castle at Airbnb, but there are no columns called castle, but we know some of the column contents. So maybe if you search for the word castle, we could actually maybe surface maybe tables that you think actually, yeah, dim room type, that's exactly what I'm looking at. So yeah, how do you sort of change the question around towards like, what's the end solution I want, and maybe you can reverse that. So partly it's just processing a lot more data and sort of aggregating that behind the scenes and surfacing it.
Let's give one last round of applause for Chris and John. Awesome. So thank you all so much for coming out tonight. We would love to meet you and talk with you afterwards. So if you have additional questions that you didn't get answered or you want to know more about what we do at Airbnb, we would love to engage. With that, anyone who works at Airbnb, could you raise your hand? All right, keep them up. So just like look around the room, come grab a person, come chat. We can stay in the room till about 8:30, and then afterwards we need to spill over into the atrium over there. But we'd love to stick around and talk with you all. One last thing is if you have like plates or dishes, if you could be a great host and bring them over to the side, that'd be awesome. Thank you so much for coming out. I think the recording is going to go up on our site. This is being live streamed, so I believe that we will share this out later, I believe. But thank you again so much, and have a good night.